Good day, viewers. I am Mr. Habila, the one taking you in chemistry. Today we'll look at a simple experiment on how to determine solubility. A simple experiment on how to determine solubility. And in our last lesson, we have looked at the definition of solubility. And we say the solubility of a solute in a particular solvent at a specified temperature is the maximum amount of the solute in moles or grams that will saturate 1 dm³ of the solvent at that temperature. Now, to determine the solubility of any salt, let's say potassium trioxynitrate 5 in water at room temperature, the method that is involved in this experiment: first of all, you prepare a saturated solution of potassium trioxynitrate 5 in water by simply dissolving excess of the salt in 50 cm³ of distilled water and stir thoroughly until equilibrium is established between the solution and the undissolved solute. Then you filter the solution. You weigh a clean, dry evaporating dish. Put some of the saturated solution and weigh again to know the mass of the saturated solution. Then heat the solution to dryness on a water bath until it is completely dry. Allow the residue to cool and dry in a desiccator and weigh again with its content. And you know, desiccator are apparatus that are used to dry chemical substance. Then find the mass of the solvent that was evaporated and the amount of the solute that dissolved in the amount of the solvent. You express it in terms of moles per dm. Now, assuming from the experiment and you obtain the following specimen result. You have mass of dish is equals to W1 in gram, mass of dish plus the solution is equals to W2 in gram, mass of dish plus solid is equal to W3 in gram. Now, from these three specimen results, there are quite a lot of things that you can obtain from these three specimen results. Now, you have mass of the solution can be obtained by subtracting mass of the empty dish, which is W1, from mass of the dish plus solution, which is W2 in gram. Then mass of the solid 2, which is potassium trioxynitrate 5, can also be obtained by subtracting W1, which is mass of the empty dish, from mass of the dish plus that of the solute, and it is going to be also in gram. Then when you want to obtain the mass of the solvent, which is water, it can be obtained by subtracting mass of the dish plus solute that you let it to be W3 from mass of the dish plus solution that you let it to be W2. So mass of the solvent, which is the water, will now be equal to W2 minus W3. Everything is in gram. Therefore, molar concentration of solid will now be W2 minus W1 in gram divided by the molar mass. And you are going to have another value, and you let it to be W4 in gram. Now from the values above, it can be deducted that W2 minus W3 in gram or cm cube of solvent will saturate W4 in moles. Therefore, 1000 gram or cm cube of solvent will saturate W4 times 1000 divided by W2 minus W3, and you are going to have a value, and you let that one to be W5 in moles. So W5 in moles is the solubility of that salt that you are determining in moles per dm cube. Is the maximum amount of that solid in moles that will saturate 1 dm cube of that solvent at that particular temperature that you are finding the solubility. Now let's quickly look at an example. Water was added to 50 cm cube of sodium chloride to produce 100 cm cube of a saturated solution at 25 degrees Celsius. If the solubility of the salt at this temperature is 7.00 moles per dm cube, calculate the number of moles of the undissolved salt. Given that the relative atomic mass of sodium is 23, that of chlorine is 35.5. Let's look at the solution to this problem above. Molar mass of sodium chloride will now be equal to 23 plus 35.5. And you know 23 is the relative atomic mass of sodium and 35.5 is the relative atomic mass of chlorine. And when you sum up these two, you are going to have 58.5 grams per mole. Number of moles of sodium chloride can be obtained by dividing the given mass that is in the question by the molar mass of sodium chloride that you obtain above, which is 58.5 grams per mole, and you are going to have your final answer. Your answer will now be equal to 0.85 moles. So 0.85 moles is the number of moles of sodium chloride. Then in the question you have the solubility of sodium chloride at 7.00 moles. Therefore, 100, we will then have 100 cm cube of water saturate 7.00 moles. Therefore, 100 cm cube of water will saturate 7.00 times 100 divided by 1000 cm cube, and it will give you 0.700 moles. Then you have number of moles of undissolved will now be number of moles of sodium chloride minus number of moles of dissolved in 100 cm cube. You equally have 0.85 minus 0.7, everything in moles, and it will now give you the final answer as 0.15 moles. And we'll look at solubility curves. Solubility curves. The solubility curve of a salt represents the variation of its solubility with temperature, and the solubility curve can be obtained by it can be determined by plotting the solubility in moles against the temperature in degrees Celsius. Now below is the solubility curve of different salts in moles per dm cube plotted against the temperature. And based on this graph above, there are deductions that can be obtained from this solubility curve above. 1. At all temperature between 0 degrees Celsius and 100 degrees Celsius, calcium hydroxide has the lowest solubility among the 6 compounds that are in the solubility curve. Then secondly, solubility of sodium chloride and calcium hydroxide are independent of temperature. Then thirdly, the solubilities of potassium trioxochloride 5 and potassium trioxonitrate 5 increase rapidly with increase in temperature. Then fourthly, the solubility of potassium chloride increases at a constant rate with the rise in temperature. And lastly, sodium tetraoxosulfate 6 shows a solubility curve with a sharp break at 36 degrees Celsius. This is because the salt exists in solution as sodium tetraoxosulfate 6 decahydrate, that is, it has 10 water molecules of crystallization at temperature below 36 degrees Celsius, but it gives up its water of crystallization to become anhydrous at temperature above 36 degrees Celsius. Hence, 36 degrees Celsius is referred to as the transition point. So these are the deductions that can be obtained from the solubility curve. Let's quickly look at the importance of solubility curve. 1. To separate and purify mixtures of solutes. Secondly, to determine the most suitable solvent for the extraction of solutes from natural sources. To determine the amount of solid drugs in a solution of mixture of drugs. There are other ones, you can find out the rest. Let's now look at factors affecting solubility. Factors affecting solubility. The first one is nature of the solvent or polarity of the solvent. The second one is nature of the first one is nature of the solute or polarity of the solute. The second one is nature of the solvent or polarity of the solvent. Now, these two factors that affect solubility are common. We have nature of the solute, whether the salt is an ionic compound or it is a covalent compound. Then nature of the solvent, like dissolve like. And so generally, compounds that are ionic normally dissolve in polar solvent, e.g. water, and covalent molecules normally dissolve in non-polar solvent. The last one is temperature change. Temperature change. We have reactions that are exothermic and those that are endothermic. And for a reaction that is exothermic, which releases heat to the surrounding environment, and when you increase the temperature on the reacting mixture, the solubility of such mixture will decreases. But for mixtures that heat is absorbed, that is, they are endothermic. They are endothermic, that absorb heat from the surrounding environment. When you increase the temperature, the solubility of those substances or reacting mixture will also increases. Then the last one is common ion effect. Common ion effect. This also affects solubility of a sol in a given solvent. Now, common ion effect is when you have an ion that is common to that salt that you are dissolving in that solvent, that is already present in that solvent. It will affect the solubility. Example, when you are dissolving sodium chloride in a solution that already contain an ion which is common to sodium chloride, whether sodium ion or chlorine ion, you will discover that it will affect the solubility of sodium chloride in that solution, and we refer to that as common ion effect. But when you have a solution that does not contain a common ion to sodium chloride, when you have an already existed solution that does not contain an ion that is common to sodium chloride, whether sodium ion or chloride ion, you will discover that the solubility will now increase. And that is what we mean by common ion. From common, things that are similar. And in conclusion, I have an assignment for you. The first one, mention 3 factors that affect the solubility of a solute in a liquid. Water is said to be a universal solvent. Explain. State any 2 importance of solubility. And my WhatsApp contact is there for you, and you can channel your assignment through my WhatsApp number, which is 070-6240-7605. Have a nice day.